AB is in which direction? This is the length you are talking about, right? And you know that what is force? Force is BL cross B, right?
Yes.
So what would be the AB length?
No,
What
I
would
didn't understand what you're asking.
I am asking that? Okay, so you just okay. Saad has just okay. So you see that we have this AB length, right? So this AB length is going in which direction?
Right side.
Right side. So length AB direction. Yes, walaikum salam, walaikum salam. So AB length L. L direction is in the right hand side, right? And
Yes.
magnetic field is inwards. So can you tell me what would be the direction of force? So AB and inwards, and what would be the direction of force? L cross B. Yes. Saad, you are also here. So tell me that AB direction is right, and then inside is your magnetic field. So where would be the direction of the force? Both of you guys tell. We have talked about this numerous times. Yes, understood. We have to find out because force is what? Force is L cross B, right? I L cross B. So you guys tell me what would be the direction of the force.
I cross J.
What did you say, Aisha?
I cross J.
I cross J. Okay. So L is I hat. Absolutely right. L is I hat. Magnetic field is inwards. Inwards is which direction? It is inwards, right? So inward is J direction or what direction? Outward is what direction?
Inward is minus K.
Minus K. Now you are correct. So inward is minus K and right is I hat. So I cross minus K. What would be the direction? Yes. Saad, this question is for you. Yes, hello Mariam, assalamu alaikum. So minus J. Minus J. Saad is yeah, Saad is telling me J, you are Mariam is telling me minus J. Aisha, what is your answer? So we have understood two methods, right? Methods we have understood. So apply any of those and tell me what would be the direction of force. Yes. So we are discussing the homework that I gave in the previous class. Saad and Mariam, you didn't submit, but Aisha has submitted, so that's why. Please, you guys, try those homework, right? In that way, we can understand the problem. Okay, Aisha, what did you get? You have I hat cross minus K hat. So what would be the final direction?
J or minus K, I think.
Minus J.
Yes, sir.
Okay, so you guys have forgotten everything, I guess. So whenever somebody asks you that what is the I cross or what is, so we make this diagram. Without doing anything, we make this diagram, right? So We know that I cross j is k, but we are calculating I cross k. So I cross minus k, which is minus of I cross k. So what would be I cross k from this diagram? Yes,
Minus J, so it will become plus J.
so it will become plus j, right? So you guys, yeah. So revise, guys, right? Otherwise you will forget everything. So it is very important to revise, right? Good. So yes. So this would be j hat, and we can also see the direction. So we are going in the right hand side. Our fingertips in the right hand side, and this palm inside. So this is inside. So if I curl my, so what is the direction that I'm getting?
Upward.
Upward. So I'm getting J. So L cross B, upward. So that is how I can also tell the direction. Good. So you guys see that for this case, force is upwards. So this is FAB. Now you guys tell me that the current is moving in this direction. The current is moving in this direction in CD. So what would be the direction of force in case of CD? You guys tell. Everyone apply any method and check what would be the direction of outwards. Outward is K hat. So Mariam is saying K hat.
Can you repeat your question?
Question is that now we are going in this direction in line or in wire CD. So in CD, we are calculating the direction of force, right? This is the length, magnetic field is inside. So what would be the direction of force? And Mariam is saying K hat. Yes, Aisha and Saad, what did you guys get? What's the direction, guys? In CD. Yes, Aisha?
1 minute, sir.
Okay. You can use the Maxwell's thumb rule or the IJK method. Any method. Yes, Saad and so Saad has already upwards. So Aisha, you are telling me that it is upward again. And Saad, what about your answer? Yes. Yes, Saad. What is your answer? What did you get? Left, right, up, down, inward, outward. Which direction? Yes, Saad. What is your answer? Please tell me. Or did you not understand the question? Yes. Saad, are you there?
Yes, sir.
Yeah. So, what is the direction of force in CD? Or did you understand the question? Yes. Yes, Saad. Answer, Saad. Just tell me if you don't understand, then tell me, right? Otherwise, we would be waiting for a very long time. So please tell me if you understood the yes. So understood. Oh, you didn't understand the question. So the question is that the current is flowing in this direction, in the left hand side, and the magnetic field is in the inward direction. Okay. The question is that what would be the force in this conducting wire? And we have already calculated that force in a conducting wire is I L cross. This is what we have already calculated, right? So, yeah, please tell me what would be the direction of the force. Yes, sir. Yeah, did you get any answer? Okay. So, J. Okay, Saad has also got J. So, guys, these answers are telling me that you guys should start revising, right? So, because we have so many chapters to cover, and if we are stuck at this point, then we're not able to complete those chapters, right? So, you see, we can apply. I have told you guys that we can apply both the methods. So, CD, right? CD, so L direction is what? In length CD, what is the direction of L?
Left side.
Left side. So left side is what direction? Actually?
Minus side.
Minus I, right? This is minus I. And what is the direction of the magnetic field? It is inwards. So inwards is what direction?
minus k.
Minus K. Good. So minus K. So then this guy cancels and we have I cross K. So we already know that I cross K is what? Minus,
Between.
right? So we have minus J, which is downward. So this is FCD. Okay. Now we can also understand this by Maxwell's thumb. So this is left, this is upward, this is right, and this is down, right? And if so, where is my palm pointing towards? Inside or outside?
inside,
Inside. So my fingertip is pointing towards Y direction, and my palm is pointing towards inside, right? But in our question, the okay, so in our question, the direction of current is left hand side, right? So we have left hand side, palm is inside. We curl our finger. What is the direction that we get? Downward, right? So we can use any method to calculate the direction of force. So this force is downwards. Okay, so this force is downward, this force is upward. And the magnitude of these forces are equal, right? Because this point is same distance with this point is same distance with this point same distance, this point same distance. So all the forces are upward, all the forces are down. So FAB is equal to FC, but with a minus sign, right? So this is J and this is minus J. So this is FAB and this is FCD. So if we add FAB and FCD, so this will be 0. FAB, FCD cancels out. So the part that you said, right? So the part that you calculated, FAB and CD, these are cancelling out. Okay, Aisha. Only only the AD part and BC part will contribute. So the question was what is the force on this current carrying? So the question was yeah. But how do we know that if the palm should be inwards? I did opposite, so I got upwards. Oh yes, Aisha. Okay. So you see that yes, yes. So why didn't you ask? So you see that the magnetic field is in which direction, Aisha? The magnetic field is in which direction? Yes. Magnetic field is in which direction, Aisha?
right, right, I think.
Inward, inward. So inward. We have cross, right? So this is cross. Magnetic field is in inward direction, right? Because for this current in the right hand side, magnetic field is in inward direction. So we are calculating L cross B. So L, our fingertips, and this is palm, right? So this is in the left side, this is downwards, inside. So it, so that is why this is left and palm inside. So understood.
Yes, sir.
Okay, so this is why the total force would be okay. So the total force on this current carrying A, B, C, D loop would be FAB plus FBC plus FCD plus F what? TA. So you guys already know that FAB and FCD cancelling out. This cancels out. So now only the left ones are FBC. So we should write the cause because FAB and FCD are equal and opposite. That is why they are cancelled. Now we have to calculate FBC. Right. So we already know that the force between current carrying wire is how much? Mu naught I1, I2 by 2 pi A and S. This is the current, right? Right, guys? So we have to calculate FBC. Okay. So this would be the, this is mu naught and this is I and then this is small I. And what is the length of this wire? L and divided by 2 pi and what is the distance? L by 2. So this part you have correctly calculated actually. Good. So this is FBC. But you guys tell me using the right hand thumb rule, what would be the direction of FBC? So point your fingertips towards the direction of current and your palm in the direction of magnetic field. So what is the direction that you guys are getting?
Sir, can you
Yes, Mariam, what did you say?
Can-
Yeah, your voice is breaking. So I only heard the can you part, and after that your voice got disconnected. Yes, can anyone hear what Mariam is saying?
No, sir.
Yeah, maybe so. Maybe your internet is not working, Mariam. Yeah. So okay, can I please repeat? So the current is moving in BC. Oh, in BC. Okay, so we are calculating in BC, right? So in BC, the current is going downward. Okay, and we have to, and the magnetic field is inward, so we have to find out magnitude part. We already know. This is I, length is L, and this distance from here to here. What is this distance? L plus L by 2. So 2 pi L plus L by 2. Now I am asking that what would be the direction? So your the question is, Maria, that what would be the direction of the force? Current is going downward, magnetic field is inwards. So what would be the direction of the force? Yes, everyone. Aisha and Saad, this question is for you also. So outwards. So outwards. Okay. Mariam is saying I hat. So Mariam is saying I hat. Aisha is saying outwards. Outward meaning K hat. And this is I hat. Saad, what about your answer? Yes, Saad. What is your answer? Yeah, are you saying something, Saad? So I hat. Okay. So Saad is also saying I. Okay, so we have a majority Aisha, right? What is the direction of your fingertips? Fingertips is downward, right? And magnetic palm direction is inward. So what will be the direction of the force? Or you can also check by, so L is minus I, and then this is minus K. So what would be the direction of, okay, oh, so this is minus J, minus J. DC is minus J and this is minus K. So what would be the direction that you get? Check it this way or check it using the Maxwell's thumb. Yes, Aisha, what will you get?
I.
Yes, what did you say? I. Good. So this is downward. Fingertip is downward, palm is inside. So when we curl our finger, this is right hand side, right? Or we can also check that, right? Yes, everyone, good, good. So now you guys, so you see, you guys have to revise. Otherwise, you will forget. So this part cancels, and J cross K is I. In this way, this is I. Good, good, everyone. So we have I here. Now, what is FDA? We are going from D to A. So we know that what is the magnetic force? What is the magnetic force? We already know that. This is mu naught I by length is L and 2 pi L by 2. Yeah. So okay, Mariam already. So Mariam is saying that it would be minus I. Yes. So Aisha and Saad, you guys tell. What would be the direction? Yes. So now the current is going upward, magnetic field is inside. So what would be the direction of the magnetic field? Yes, Aisha and Saad. So plus I, Aisha, you are getting plus I. And Saad, so what did you use? Aisha, what did you use? Right hand thumb rule or IJK method?
Right hand side.
Right hand thumb rule. So your fingertips in upward direction and your palm in the inward direction. So when you curl your finger, what will be the direction that you get? Plus I or something else?
Sir, plus I, right?
Plus I. So how you guys are getting? So let's see. This is upward, right? Fingertip upward, right? Palm inside. Curl my finger. What is the direction that you guys will get? Yes,
Minus I.
minus I, right? So Aisha, what will you get? Plus I or minus I?
Minus I.
Right? So this would be minus I. Okay, so and whenever you guys are confused, so you guys can use the IJK method, right? So what is this DA? What is the direction of DA? It's J hat. And then magnetic field is same minus K. So J and K is what? Oh, what did I write? So, okay. So J and K is I. So minus I. Right. So I can always check with the IJK method. So so this would be minus. This is minus. Okay. So if I add these two, so total F would be F net as you have calculated. So this would be, this is 2 cancels, and this is what? So this is 3L by 2. So mu naught I and L, and this is 2 pi, and then this is 3L by 2. So this 2 cancels, and L cancel, L cancel. So what we will have? We'll have mu naught I by 3 pi, and then minus of, this is I hat, and then we have mu naught I pi pi, and so this is 3 pi, and this is mu naught I, and then minus of, this is what? 3 mu naught I whole. Right. So this would be minus of 2 mu naught I by 3 pi. So this would be minus. Minus meaning that the force would be attractive in the left hand direction. Okay. So this is what you will get. Understood, everyone? So they would be minus n, but this is not FAB and CD. This is BC minus of so BC minus of T. So this would be the answer. Okay, clear, everyone? So is it important to find the direction as well in such question, or only magnitude is fine for exams? Okay, yeah, but direction is important. Why? Because you can see that there would be some negative, right? So why this is negative? This is only because we have this minus sign. Yeah, so you can only calculate the magnitude, but we have to remember. So if we can remember that, yeah. So if we remember that for the parallel case, what is the force? What is the force for the parallel case? Yes, we have talked about this, that if we have parallel currents, so what was the force? It was attractive, right? And if we had anti-parallel, so force was repulsive. So what we can do is that we can calculate this one and we can calculate this one and subtract them. So yeah, you are correct, absolutely correct. But this is not AP and CD, this is BC and D. Okay.
Yes.
Okay, so yeah, if you guys understood, so please write it down. Please write this down. And as Aisha is saying, so we can directly write the answer as well. So F net would be only the magnitude part. So F, and what was that? BC minus FTA. So we can directly calculate that. Okay. So this is mu naught I and L divided by 2 pi, and what was the that? L plus L by 2 minus of mu naught L by 2 pi, and this is L by 2. So in this way we can also calculate. We will get the same answer. So minus 2 mu naught I by 3. We'll get the same answer. So this is only telling us that this net force would be attractive. So if we can write, This would be 2 mu naught I by. So this is the answer. Everyone understood?
Yes, sir.
Okay, so yeah, good that you tried these questions. So I'm yeah, Saad and Mariam, you guys also try the homeworks question, and then we can discuss about those questions, right? Otherwise, there would be so many doubts and confusions. So it is better that we can discuss those doubts in this class, or if we have the doubt in the exam, then that would be problematic, right? So if you do the homework, then you would be able to understand that whether you understood the question correctly or not. Okay, noted everyone.
Yes, sir.
Yes. So then we will discuss these questions in the next part. So day after tomorrow we'll discuss these questions. Okay, Aisha.
Okay, sir.
Next chapter, I will start with the sixth chapter. The fifth one is the major portion of the fifth chapter is theoretical part. So we have only the definition, ferromagnetic, paramagnetic, and diamagnetic, or these kind of magnetic. So we don't have any derivation as such in the fifth chapter. So what I will do is that I'll send you the notes of this sixth one, and then we will discuss those notes. But today I will start EMI. Okay.
Now the fifth chapter is over.
Yeah, fifth chapter is what?
The fourth chapter is over.
Yeah, fourth chapter is over. So we did the galvanometer, right? Galvanometer and the conversion of galvanometer into voltmeter, and so this part we did, right?
Yes, sir.
So that is why, yeah. So the fourth chapter is finished. Okay. So yeah, let us start this chapter. And you guys, please, for my sake, start revising. Otherwise, there would be so many doubts, and I don't uh, want your doubts to haunt you in the exam, right? I want all your doubts in this class. So please, you guys start revising. Otherwise, you have to cover so many things in such a short span of time. So your school has reopened. Saad and Mariam, your school has reopened, right?
Yeah, sir.
Yeah, so start revising that, right? And I'm here if you have any questions, any doubts, so we can discuss this here, right? Because
So,
if you will revise, then you will get to know that, yeah, you have some doubt in here and there. So then we can discuss this stuff. So please start
oh,
revising. Okay.
okay, sir.
Okay. So the first, yeah. So in the third and oh, my voice is cracking. Maybe there's problem with your internet, Maria, because yeah. So Mariam, I'm saying that please start revising. Otherwise, in such a short span of time, you'll have to cover so many of syllabus. So I don't want you guys to take that kind of pressure, right? So it is better that we revise bit by bit. We don't revise the most of the portion in a day or two. So yeah, okay. Yeah, so and I will also try to give you guys a quick revision, but let us move on ahead and complete few chapters. Okay, so in the third and in the fourth chapter, what did you guys learn? So in the third and fourth chapter, we understood that we had some conductors, right? We had some conductors, and then we applied some current in the conductor. So then what happened? What happened when you applied some current in the conductor? What did you get? Yeah, somebody is talking, but I cannot hear. What did you guys get when you applied some current in the conductor? Yes. What was about the third and fourth chapter, especially the fourth chapter? Who is talking, but I cannot hear. Yeah, so when we apply the electric current in the conductor, then we got magnetic field, right? Am I? Is this correct, everyone? So we got magnetic field due to current carrying wires. Now in this chapter, we will learn that is there a reverse effect or not, right? So we know that our nature is very symmetric about it. So whatever we give, it will give us back. So we are applying, if we are applying current in the conductor, so we got magnetic field. But what happens when we apply the magnetic field, or when we change the magnetic field? So what we will get? What we will get, guys? Yes. Yes, guys, what we will get? Somebody is talking, but I cannot. Yes, what we'll get, guys? So we will get current, and to be precise, so we will get current, but to be precise, that would be induced current. So yes, absolutely right. So that is the idea of this chapter, which is chapter 6, and the next chapter as well. So this chapter is about electromagnetic induction. So when we have this magnetic field, then we will have some induction, right? So some voltage or EMF will be induced, and due to that, some electric current would be there. Induced current would be there. So this is EMI, right? And then in the AC chapter as well. In the AC chapter, we will also learn about this induced current when we talk about transformers and all. Okay, transformers, dynamo, and all. So this is what is about this sixth chapter, EMI. Okay, so to understand that first, can you guys recall what was this phi, or let me say
Flux.
electric flux, right? So what was this electric flux? Do you guys recall what was this electric flux?
By epsilon. Q by epsilon 0.
So that is Gauss law. That is inside a closed surface, right? Inside a closed surface, the flux is Q by epsilon. I am asking that what is this electric flux?
It's the total number of electric field lines passing through a surface normally.
Yeah, yes, absolutely right. So we have this surface, right? And the electric field lines, electric field lines. passing through this surface normally, right? So that is what we call number of field lines passing through this surface, right? Normally meaning perpendicular to this surface. So that is what we call, and let's say the surface area is A. So what was the phi? Do you guys remember?
E.
E dot, right. So E dot or EA cos theta. Good. So this is electric flux. Okay. Similarly, we have a magnetic flux. Right. So it is denoted by phi. Okay. So we have this surface area and the number of field lines passing normally to this surface. So what is the, in case of this diagram, what is magnetic flux in this case? Yes, according to this diagram, what is the magnetic flux?
Sir, can you
Okay, so I have this diagram. This is some surface area and these magnetic field lines are passing normally to it. So I'm asking that what is this magnetic flux? How much would be the magnetic flux? So I have not given you, so what is the definition? Definition is number of magnetic field lines passing normally to the surface. So if I say 1, 2, 3, 4, 5, this is the magnetic flux, right?
Yes.
This we don't know magnetic what is magnetic field. We don't know what is area, but we know that how many number of field lines are passing. So that is what the magnetic flux, right? Okay. So this is the magnetic flux, and this is represented by for a uniform magnetic field, as you guys are saying, this is B dot A. Good. So this is also correct. And this is BA cos theta. Let me write the. Okay. So where theta is the angle between the area vector and the magnetic field. Okay. So if I ask you guys that if I ask you that uh, this is my, let's say, this is my surface area, okay, and the magnetic field is going like, okay, so this angle is, let's say, 30 degrees. So what would be the angle between surface area and what would be the angle? What is the theta in this case?
30-degree?
30 degrees. So recall that okay, Mariam is saying that it is 30. Aisha and Saad, you guys step. So remember that the angle theta is between the area vector and the magnetic field.
60
So
degree.
60. Okay, so Aisha is saying 60. Saad sir, what is your answer? Yeah, we'll go very analogous to the first chapter. So that is why the first two chapters are very important, or first three, I should say. Saad, what is the angle? Yes, Saad,
60. 60.
60.
Yeah.
Good. So, Mariam, you understood why this would be 60? Because if this is the surface, then what is the direction of this surface? What is the direction of this surface? If we have this surface, so what is the direction of this surface? Right? This is the area. So, and this is the area. So, what is the direction of the area vector? Yes, Mariam. If we have, this area, this area, this is the area, this is the plane. So, what is the direction of the area vector? Right? Area vector or area is a vector quantity. So, what is the direction of the area vector for this surface? What would be the direction of the area vector? Yes, Mariam. Oh, you have forgotten. Okay. So the direction, can you guys help Mariam, Aisha, and Saad? Yes. What is the direction of area vector, Aisha and Saad? Yes, Aisha and Saad. Why you guys? This is always normal to this surface. Always normal to this surface. This is the direction of the area vector. So this is A and this is n hat. So this is the direction of the area vector. This is the direction of the area vector. Normal to this surface, right? So if this is the area, so the direction would be this one, normal to this surface, right? So this is, I have, this plane. So this is my plane, right? So this is my plane, and the direction of area vector is this one. Okay, Mariam, is this clear? Mariam, is this clear? Okay, so your voice is not audible. So this is always perpendicular to the surface, right? And this is 30 degree. So from this is the plane of the area vector, and this is making a 30-degree angle. So this angle would be 60. So the angle between magnetic field and the area vector is 60 degrees. So this would be 60. Understood, Mayam? Understood.
Yes, sir.
Okay, so this was about magnetic flux. And what kind of quantity is this? Is this a physical scalar quantity or vector quantity?
Scalar.
Wait.
Scalar quantity. So it is a scalar quantity, right? And its SI unit, SI unit is, you see, what is the SI unit of magnetic field? What is the SI unit of
Tesla.
Tesla, right? So this is Tesla, and area is what? Area is,
Meter square.
so this is Tesla meter square, right? So the SI unit is Tesla meter square, and it is also written as Weber, right? So Weber, which is represented by W. Okay, so this is what we call about, or what we say about the magnetic field. So you guys please note it down from here. Okay, and if you guys have any doubts, so please ask. Okay, I will write it here that the direction of area vector is normal to the plane or surface. Got disconnect. Learnivio got disconnect. So whenever you guys want me to scroll down the screen, you guys tell.
Sir, can you please scroll down? Done, sir.
Done. Aisha and Saad, what about you guys? Done. Saad?
Done, sir.
Okay, so let us do few simple questions, right? So find for the magnetic field of 4 Tesla is inclined at an angle of 30 degrees with the plane of the area, let's say 20 meters square. Find the magnetic flux that. Okay, very simple question. So you guys calculate and please say. Yes, guys, got any answer?
80 root 3 by 2
80 root
Tesla meter square.
80 root 3 by 2, which is 40 root 3, right? And we can write Weber. So this is my answer. Okay. What about you guys? So first we have to draw the diagram, right? We have this plane. We have this plane and the magnetic field is inclined at 30. So then we have to figure out, okay, so yes, what is 5 VA cos theta? Yes, Aisha and Saad, what did you guys get? Oh, so you want to change your answer, Maria? Okay. So Maria want to change her answer. This is she's getting 40 wave. Aisha is also getting 40 wave Weber. And Saad sir, what about you? Yes, Saad,
Yes, sir.
what about you? What is your answer? What did you get?
One second, sir.
Yeah. So you have magnetic field B, you have A, you have theta. All the things are given, right? Oh, you don't. Okay, good. So yeah. Okay, so you see, Saad, we know that magnetic flux is this, right? So how much is the magnetic field? It is 4 Tesla. So this is 4. And A is how much? A is 20 meters square. And cos of 60. So this is 4 into 20. And what is cos of 60, Saad? 1 by 2. So this is 2. So we'll get 40 Weber. Yes, good, Maria Menaj. So you guys, yeah. Saad, you please note it down, and if you have any doubt, please ask. Okay.
Okay, sir.
Yes, please note it down. And if Aisha and Mariam guys have not noted down the question, then please note down the question as well, because the answer you already. Okay, noted, I guess. Yeah, yeah, we have an assessment. So we have an assessment, right? Okay, noted, everybody. What is the assessment on? So it is on the second topic of chapter number 4. Maybe the use of application of Biot-Savart's law. So maybe magnetic field on straight wire or semi-infinite wire. So maybe this is the top. Okay, noted everyone.
Yes,
Yes,
sir.
sir.
Okay, so now again a very simple question. So the magnetic field in an area is 3i plus 2j plus 5k, right? And this is passing through an area of, let's say, 2i plus 5j plus 2k. And this is meter square, and then this is Tesla. So find the magnetic flux, right? So you guys quickly calculate and tell me the answer. So I wanted to complete the at least Len's law I wanted to complete. But okay, so was says there no specific specified degree, so we take it or as normal to the surface. Okay, Mariam, so what do we have? Pi is B dot A, dot product, right? You think about it. So what would be the dot product? We have done the vectors part, right? Yes, who's got the answer? Oh, Saad got disconnected. Yes, so what is the dot product? So do you guys remember or not? I dot J, I dot K.
1 second, sir.
So 26 Weber. So Mariam got 26. Aisha, what did you get?
One minute, sir.
So please calculate and tell. 26 Weber. Good. So you guys both guys. So we know that only I dot I will survive. So this is 3 into 2 plus j dot j. So 2 into 5. And then this is 5 into. So then this would be what? 6 plus 10 plus 10, which is 26. Good. Good, everybody. So now this was about the magnetic flux. Now what happens is that the next is Faraday and Henry's experiment. Okay, Saad, you got disconnected somehow. So this was the answer. Okay, Saad, you please note it down, and if you have any doubts, so please ask. Yes, Saad, please note down this question. Note it. Okay, so before we do the next question, so we have this, right? This is the bar magnet, and it has north and south pole. So it is a dipole magnet, right? It has two poles. So magnetic field starts from here and then comes to here. Okay. And magnetic field line start from here and then comes to. Okay. So magnetic field starts from here and then in this side and then is this side and then this side and then this. So these never intersect, but due to my bad handwriting, so this is appearing to be intersect. So it starts from here and then comes back to here. So it starts from here and then comes back to here. So, okay, and exactly similar to a solenoid. So we have this solenoid. So this is exactly similar to a solenoid. Okay, same diagram. Okay, so this has also the same diagram. But inside it goes from south to north. Okay, so this is the diagram of a magnetic field lines of a bar magnet. Okay, now what happens is that time is over. So what happens is that the two people they studied what happens when you move this bar magnet. So we have this bar magnet, right? This is north and this is south, and the electric field lines are going. Okay, and you place a coil adjacent to. You place a coil, and it is connected with some galvanometer. Okay, so we will see that what happens with this coil. Right. In the next class, we'll study about the Faraday's experiment. Faraday's experiment. So this is first diagram. We'll have second diagram and third. So we'll study all these three cases, and then we'll see that what happens with this galvanometer. So what does the galvanometer do, guys? Yeah, what is the use of the galvanometer? Do you guys remember? We just studied the galvanometer.
It is used to detect the presence of current.
Presence of current, yeah. It detects the, yes, very good. So it detects the presence of current. So to check out how much current. Yeah, so not how much current, but only the presence of current. So much part is answered by ammeter. Ammeter measures how much current is passing, but galvanometer just detects the presence of current. So we'll see that if the deflection is happening, then the current will be passing, right? So we'll see that in which case this deflection is happening through this coil. So this is the coil, okay, and this is what? This is some magnetic flux through this coil. This is phi b, and we will see that what happens when we change this magnetic flux. So you guys please log into your Learnivio account and start the active test. And in the next class, we'll talk about this Faraday's experiment. Okay.
Okay.
Okay, please log into your Learnivio account and tell me whether you got the active test or not.
Yes, it's there.
Yeah, it's there. Okay, so please start the test, and if you have started, then you guys can do, right? But please complete that. So whenever you start, then you guys can. Okay. Yeah. Bye Aisha, bye Mariam, and bye Saad. But please
Next
start.
one.
Yes, Allah Hafiz, Allah Hafiz. Here you guys start the test. Mariam and Saad, did you get the test?
Yes, sir.
Okay, so Allah Hafiz, guys. See you.
Allah Hafiz,
Day,
sir.
yes, see you day after tomorrow. And you guys start revising, right? Start revising. Yes, bye guys. Allah Hafiz too.
Sir?
Yes, yes, Saad.
Sir, I didn't got, sir.
Oh, this time again you didn't get. Hmm.